Let's look at toxicity of sulfur. Sulfur at high levels is toxic. Basically, at a high level, you've got the ionic form. The ionic form is really an acid type form. Therefore, it is going to cause toxicity by burning membranes and decomposing membranes. It's going to cause a change in the pH. We did say that the gaseous forms of these materials can be absorbed. Often they are absorbed as an air pollutant, especially when there's excess amounts in the air. This can get to be a very strong problem on different types of material. The higher levels are toxic. Glutathione can help moderate this. Remember, glutathione picks up the material, it takes it out of the ionic form. It will help stabilize your pH. In that, we've got a very important part of how these things can actually moderate. We often talk about oxides of sulfur. It could be SO2, it could be SO3, it could be SO4, it could be H2S. There are a lot of different formats that you can find sulfur in. It can carry on many different valences. Therefore, some of these are toxic, they are problematic. A lot of these are emitted when we're burning fossil fuel. Remember, the organic material picks up the sulfur. The sulfur is therefore part of the residue. As you burn the residue, that is going to emit off the sulfur. When we deal with coal, coal normally has a maximum of about 1% sulfur. That means in every 100 tons of coal that you burn, you release 1 ton of sulfur. That's an awful lot of material. Sulfur actually is important in here. And when we look at these materials, we talk about different types of concentrations. In coal, there's a difference between anthracite coal, which is hard coal, and bituminous coal, which is soft coal. Bituminous coal has more sulfur in it than the anthracite. In crude oil, this shows you the different types of sulfur. If you've got no sulfur in it, these are considered to be light, very important type of materials. You don't have to go through the process of removing the sulfur out. If you look at the Alaskan North Slope, you're looking at about 1%. If you're looking at Arab light material, you're looking at about 1.5%. This becomes important when we understand things about toxicity. The toxic form that you get is when all of this material is burned, it's released into the atmosphere. In the atmosphere, the sulfate combines with water to give you sulfuric acid. The sulfuric acid serves as nucleation sites for the raindrops. It gets picked up by them. These drop out of the sky on the ground. You now have acid rain coming in on your plant material. It's either going to burn the plant material directly or it's going to moderate the pH of the soil such that the soil is no longer going to be fertile. We've got to be able to deal with the toxicity part, the other problems that we get in here as well. Where does sulfur come from? There's a lot of different ways we put sulfur down on the soil or we get sulfur into an available form. This looks at the bacterium Thiobacillus thiooxidans. Thio refers to sulfur. So this is a sulfur bacillus that oxidates sulfur. If you put pure sulfur down, elemental sulfur, the Thiobacillus thiooxidans in the soil will pick up the sulfur and acidify it and turn it into a sulfate form that will be available. I saw an experiment done with this once. By moderating the sulfur content, within 60 days, the pH was able to drop down to about a pH of 1, which is just too strong for anything to actually be able to grow in it. When we look at these, it becomes important to understand how this works as well. We get sources from the burning of coal and petroleum. This becomes a fair amount of sulfur in the air. As we have that sulfur in the air, it can come down on plant material. If it is properly moderated, it will serve as a beneficial type. We get it from volcanic material. When a volcano decides to blow its stack, we get various oxides of sulfur being released. Now, this is one we don't always think of. Groundwater. Sulfur is readily leached out of the soil. As you leach it out, it's going where? It's going into the groundwater. As you pump your groundwater out, you spray that back out on the field, you may be supplying a sufficient amount of sulfur for the plant to be able to grow. We don't always think of things like this. Groundwater can be very important if we are going to artificially apply sulfur. You can apply the elemental sulfur. The elemental sulfur is going to cause a lowering of the pH because of the Thiobacillus thiooxidans in the soil. When we look at recommended sulfur rates, 30 to 100 kilograms of sulfur per hectare for oilseed rape. If you're planting canola, you're looking at 30 to 100 kilograms of sulfur. Compared to what we've been talking about, some of the other things on nitrogen, that's not that much. If we're looking at a cereal, we're only looking at 20 to 50 kilograms of sulfur per hectare. The other thing we have to look at is sulfur is often applied as part of other chemicals. When you apply potassium, you may apply it in the potassium sulfate form. When you apply nitrogen, you may apply ammonium sulfate, iron sulfate, magnesium sulfate, which is Epsom salt, copper sulfate, which is probably the most available form of copper you're going to find, calcium sulfate, which we call gypsum, which is very important. Sulfur is often applied in fertilizer as part of other chemicals. Therefore, you'd have to be able to calculate out what your sulfur content is in the other chemicals. This is one of the reasons why we don't necessarily go out and actively incorporate sulfur in. Sulfur fertilization reduces the uptake of boron and molybdenum. Sulfur fertilization is an effective tool to reduce selenium, molybdenum, arsenic, bromine, and antimonium uptake on contaminated sites. If you've got a site where you've had some sort of contamination of these materials, you can add sulfur, and that's going to reduce the uptake of some of these metals. Non-metals, we do see an interaction in here. There is a significant increase in the uptake of copper, manganese, cobalt, nickel, and cadmium with increases levels of sulfur. This is due to the acidifying effect of sulfur. Go back and review under the lime where we had that chart that showed where things were available. As you acidify things slightly, you'll get increased availability of some of these. This last part in here is very interesting. It talks about synergism. You get a synergism between sulfur and selenium. Increased selenium in the soil helps increase sulfur accumulation in the plant. This is a type of synergism. Sulfur and phosphorus on crop yield occurred for sorghum, maize, wheat, and mustard, which means you had a synergism between sulfur and phosphorus on plant yield. They've also found that there is a synergism between sulfur and potassium on many plant species. When we're dealing with sulfur, we have to look at our soil nitrogen levels, we have to look at our phosphorus levels, our potassium levels, because there is an interaction among all of these. This is not something we always think about when we are dealing with fertility or fertilizers. Sulfur seems to be one of the more active materials and is very important in plant growth. Therefore, we need to be able to be cognizant of what's going on with sulfur.